All right, so we are here at the mobilityDCAT-AP webinar. I welcome you all. This is a NAPCORE project, as you know, and mobilityDCAT-AP is a mobility specification for mobility data portals, specifically national access points. You should be all familiar with mobilityDCAT-AP. There already had been a webinar last year, which explained all the background and some basic information. If you're still interested in this previous webinar, you can check this website. You will find the recordings, you will find the PowerPoints. So feel free to check the previous one. Today we will
Sorry, Peter, you're not sharing the right slide, I believe.
No?
We are seeing the presentation in presentation, not in presentation mode.
Okay, so I will just do a different mode here. I'm sorry for that. Okay. Okay, so this should be better. Okay, you see the full screen presentation, Mario?
Yes.
Perfect, thank you. Again,
yes,
so
now it's perfect. Thank you.
Exactly. So this is the recap. You see the link at the bottom. Feel free to check the recap of our previous webinar. Today, however, we will deep dive into a more specific topic here of mobilityDCAT-AP. I will give you a little glance on the current updates of the mobilityDCAT-AP model. Then we will deep dive through different validation aspects. I will introduce some colleagues of mine who will take over. And at the end of the session today, we will have opportunities for you people in the call to ask questions, and we will try our best to answer those. What is the goal of today? I would like you people here to have outputs like this when you do your deployment. So they are validation tools and programs who hopefully give you outputs like that. So you should have error-free validation results. And the session today will guide you through how to get to this point. So you need to know what is the best way to ensure that mobilityDCAT-AP is well implemented in your systems. You will get some knowledge and guidance how to validate your individual deployments. So you will learn about validation concepts, tools, and practical deployments. The target audience are persons or organizations who would like to implement mobilityDCAT-AP, or maybe people who are already doing so. mobilityDCAT-AP, as stated before, is a metadata specification published by NAPCORE. It has already some little history, so we are already advancing in terms of releases. There has been a new release, 1.10, published early this year. It's a minor semantic release. You know this respec website where you find all the data model, all the information and all the artifacts. Of course, as in any data model, we are collecting issues, questions, problems. We do via GitHub, so you know our GitHub repository. And of course, because it's a very new specification, we try to support early adopters, specifically national access points who are deploying mobilityDCAT-AP. Talking about early adopters, there are already many of those. We have a list of adopters, which you also find on our GitHub. So at the end of today, we have six NAPs who have deployed mobilityDCAT-AP, which from my side is a very successful story. And there are some other NAPs on the way to deployment. So it's reaching out across the continent. We are not stopping our work, so we will most likely in summer this year release another major release of mobilityDCAT-AP, which will align and adopt the super specifications that we're using, specifically DCAT-AP version 3 and GeoDCAT-AP version 3, which had been released previously. So those ones will be adopted and incorporated in our own model. but this is something on the way. So this is all from my side, because the rest of the day I would like to give word to our experts and colleagues of NAPCORE who will guide you through some specific topics. First, I will invite Mr. Daham Mustafa. He is a data engineer at the Fraunhofer IWI Institute here in Germany, and he is one of our experts in terms of the data model and the GitHub representation, specifically the SHACL framework. So now I will close my screen and I will give floor to Daham. Please let us know what SHACL means, and then we go from there.
Yes, thanks, Peter. Hi, everyone. And slightly correction for your slides, my affiliation is Fraunhofer FIT. I'm Daham Mustafa. Yeah. I'm researcher at Fraunhofer FIT. My main research areas is LLMs and knowledge graph. Yeah. I have prepared some contents to present here. First of all, I'm going through some theoretical concepts, and later we will see some examples on practice how to validate SHACL shapes. First of all, the question is what is SHACL and why we use it. SHACL is a machine-readable language which can be used for validation of RDF data. And we are using this SHACL shape for validating the data resource, the structure that we want. And if you want to see some analogies in real world, for example, if we want to collect some data online, of course, we have some specification that our data should follow. For example, we are interested for a valid email or some specific format for phone numbers and so on. The exact same thing is SHACL caring about RDF data. It's the complement of how this constraint should be applied in our data. Then what's happening if we don't use SHACL shape? If we don't use SHACL shapes, maybe the quality of data or the things which we are expected is not going on. Then the SHACL is just improves the quality of our web applications and enhance the data reliability of semantic applications. Of course, we have also OWL, which is an ontology language, and sometimes people are asking why OWL is not enough and why we think about SHACL, because OWL is just following the open world assumption. That's the theoretical concept in the computer science, which is say that we have not a prior constraints on our data. And also because the OWL is not the validation framework, it just has limitation on the constraint. Therefore, we cannot exactly use for some properties. For example, if you want to have one exact property for a specific data, we cannot have this by using OWL. And also OWL is just built for inferencing and reasoning. It's not for validation. But the main purpose of SHACL, which makes the world closed, means it is following what we want to do, and also that SHACL can enforce every constraint we want. For example, if we want to have exactly one data value for a specific property, we can enforce that by using SHACL shape. And also the SHACL shape is because, as I said, a machine readable and can that enforce automatically. Then here is about the open world and closed world assumption. This is if we want to make our world close, of course, we are using SHACL shape. And in SHACL shape, we have two parts. One is called the core or the base components of SHACL shape. And also we have advanced feature of SHACL shape. The main core components include the shapes, which is defining the constraint on a specific RDF resources, for example, or literals. We will come to this technical concepts, and for the validation, the core of SHACL can validate any RDF shapes, and also we can apply simple constraints by using the core of SHACL. But if you want to go to further with the very advanced relations and advanced constraints, of course, we need to use advanced features of SHACL shape, which is like inferencing and extensions, and also we can use SHACL and so on. But this part's very advanced for our use case. We don't need that. We can validate everything in our DCAT API with just by using the core of SHACL shape. And here's I'm just explaining some technical terminology about basic concepts which we are going to be used in SHACL. First of all, RDF is it's a resource description framework which is modeling the facts in the triple, like subject, predicate, object. Like here, if we have this sentence, we can easily represent and model it in RDF. IRI also is a unique web address identifier for any entities on internet. And the ontology is a structure or a blueprint for using or modeling things. And we can have different ontologies for a specific domain and so on. Literal is an interesting concept here in our SHACL shape because the literal is everything which can just contain the text, numbers, and so on. The node is the graph that can have a specific property. For example, a book can be a node in our graph, which has title and author. And the graph is a collection of RDF triple. And we save this RDF triples in a different serialization. Mario will explaining that this serialization. And also we have resource. The concept resource is very important in SHACL. Anything can be assigned with a unique URI. And here in the SHACL, if we want to validate a specific entity or resource, we call it resource in SHACL shape. And also we have some specific other terms related to SHACL shape, like what is namespace and what's prefixes. Prefix is like a short representation of any namespaces. Here we can represent this namespace. The namespace is usually referencing to some human readable documentation or some other namespaces on web. And then we can write this whole to the specific prefix. This is called the prefix. And for example, in our SHACL shape, in our practical example, we see a lot of prefixes like this SHACL prefix, which is a namespace for SHACL shape vocabularies and DCAT and so on. And in SHACL shape core, if we want to define a specific shape, what we should know or what we need, especially if we want to just use the core features. First of all, we need to know about node shape. The node shape here is the resource definition. We are using this prefix of SHACL, and then we can define any instance of this class as a data shape. For example, we can define this data shape for this specific class by using node shape and the concept of target class. And if we want to just, after creating this shape, we can use also the shape property, SHACL property, or creating a specific constraint on a specific data property. For example, here, by using the SHACL path, we can say that the title, for example, we are targeting title of DCAT dataset, and we can add more cardinality, more constraints for that. For example, we can say that at least we want to have one property of DCAT, and at most we want to just have one property from this one. And this is like a mandatory property. Whenever we are creating any instance of the class dataset, we should at least have one, at most have one DCAT title. And we can use also other constraints, like we can specify which data type this DCAT title should have. For example, here we can use not kind from SHACL. We can define it as a SHACL literal, means the title should be of type string. And we can also define a specific range, how many times this can be occur or so on. We can use the mean inclusive and max inclusive from SHACL. or we can just directly specify not as a literal, but as a string. And we can also apply the specific pattern. For example, for property mailbox, we can say always this mailbox should follow the specific pattern, means a valid email. And we can use this SHACL pattern vocabulary. And also we can validate logical constraints. For example, if we have DCAT title and name, we can use, for example, we can say for our data set, we should have at least one title or one name. Then we can use the SHACL or. And also for the, we can reference the shapes which we have defined previously by using the SHACL node, which is reference to another shape which we have already defined. And also we can use targeting rule, for example, which target class, which target node, or which target subject of the specific data set we can, the specific property we can use. And also we have some result or some we can customize the, when the result property is returning the violation report. For example, in the SHACL, if our shape is not pass, then we can use the SHACL message to customize our output. For example, we can say each data set requires a title. If the title is missed in our data, when we validate our shape, we will get this message. That's for making things more human readable. And there's another features can be also used in parallel with the core, like inverse property constraint or closed shape and so on. But we have not used this one. Just I put it here as an additional information. And we can also use, like, we can deactivate a specific function if we want to deactivate this data set shape. We can use SHACL deactivated. And also for some others, that's some other advanced features which we don't need in our mobilityDCAT API. You can write, of course, Sparkle inside some SHACL shapes and so on. Here's about best practice. Also, Mario is explaining this part. Another part, we will see that in our practical examples, a lot of about prefixes and about namespaces. In our SHACL shape, DCAT API SHACL shapes, we have used all those prefixes. As I said, that's a namespace. And always namespace is referring to some human readable documentation. For example, if we use this one, redirect to the mobilityDCAT API version 1.1, and we can represent that prefix here as a custom prefix. This is instead of writing every time this long line, we can just use this prefix, and for other ontologies as well. And yeah, here I just explained it how you can use the short prefix and what the other ontologies are referring to, DCAT and FOV and SCOS, so on. And also, yeah, one problem is in always when people is validating SHACL shapes, the namespace and prefix are very important. For example, HTTP and HTTPS are two different things because both of them are not referring to same place. Sometimes it happens that people have this HTTPS in their SHACL shape graph, and the other side using HTTP, for example, and this is not validating. We will see in the practice that that prefixes are crucial and important because it takes a lot of time to find that tiny errors in SHACL validation. I think this part would be explained by Mario about SHACL Playground APIs. And yeah, I'm handing over to Mario to explain that, and then we will go to have a look about DCAT, different shapes, and how to validate some of these examples.
Okay. So for the rules, everyone in the call can use the chat anytime to place questions. We are pretty good in time, so I will, yeah, there will be room for Q&A at the end. Before we move on, I would like to let you know that you have seen a GitHub repository, which of course has the validation guidance embedded. So we will send out the links when we do our recap. So all the materials and the GitHub is available for persons. Maybe we just do one first question because we are really good on time. So I see one question here from Arthur. No, it's not a question, it's a comment. No, it's even a better explanation how the context of XML, RDF, RDFS, and OWL is shown in a stack diagram. So thanks, Arthur, for that. Yeah, so again, everyone feel free to use the chat. I will make sure that everything will be covered here during the call. In the meantime, we have another gentleman here in my team. It's Marius Kotschak. He is a knowledge engineer for SHACL in Milano in Italy, and he has been helping us for many years with developing the data model and the technical toolset for mobilityDCAT-AP. So Mario will now deep dive into the tooling or the tool sets that you people might use for validation techniques. Mario, please.
Thanks, Peter, for the introduction. I'm happy to be here and to explain a little bit more about the validation of RDF. As Peter said, I'm knowledge engineer in SHACL, and I mainly work with these technologies every day. So feel free to ask me whatever question you may have. And thanks, Arthur, for sharing this diagram. This I think I also find it really useful to explain to other practitioners how the semantic web stack is composed. So before going to the tools, I wanted to make a clarification about one thing that is always a little bit misleading for people going into the objective of validating RDF. So first of all, we have to distinguish about syntax validation and schema validation in RDF. And this is the same as the difference between validating an XML and validating an XML file against an XSD schema. So the first part is about syntax validation. The question is, am I generating a valid output according to one of the RDF syntaxes that I am considering? And the second one is about schema validation. So in this case, I'm asking myself, this RDF, that is a valid RDF, is also compliant with the given specification. So in our case, it is compliant with the mobilityDCAT-AP specification. And so now let's go a little bit deeper into these two phases. So the first one, as I said, is syntax validation. So here we have to check that the textual content that we are processing is compliant with one of the RDF serializations. So RDF allows you to, let's say, express an RDF dataset in different serializations. I reported here the most common one, more common one that are RDF XML, Turtle, JSON-LD. And each of these serialization has its own rule to represent RDF data. And there are W3C specifications that you may check on the web. My suggestion for someone that is not very familiar with these serializations is to start from Turtle, that is quite human readable. So you know, all RDF is both machine readable and human readable. Turtle, I believe, is the most let's say easier to read. How can you do this? So first of all, of course, you can do it programmatically. So you can choose a library that supports RDF. There are a lot of libraries out there that are able to do so. The more common are RDF4J or Gina for Java and RDFlib for Python. But I put here also a link that contains many resources about using RDF. And here for every programming language, you will find libraries that are able to process RDF. And finally, there are also other tools. And now I will show you some of these. that can be used for quick check and experimentation without installing anything on your PC. So just going online and trying to do something like that. And just, let's say, to finalize, also here I put this image just to say the objective of this phase is only to say this text that I'm showing here is valid RDF in the Turtle format. So a first tool is this one from Zazuko, that is a company that also works and provides many open source tools related to semantic web technologies. This is available online, but you can also install it as a VS Code extension. It allows you to go from one serialization to the other. The box in the right, in the left corner, allows you to change the serialization and see your RDF in different formats, and also allows you to see the graph as a sort of graph visualization that you can see here in the right, where each node is represented as a box and is connected with the other nodes referenced. And this is great for visualization. Maybe it's not really straightforward in case you made some errors in the RDF to understand where the error is. For this reason, I may suggest you also to check this tool that is RDF Shape. And this is online and supports different operations of RDF. Everything is documented on the website if you want to check it. And here I believe that the validation errors are reported with more details on the right, but on the contrary, the visualization as a graph is a little bit basic. And related to syntax validation, I wanted to raise this common error that, let's say, I encountered many times when talking with early adopters of mobilityDCAT-AP. Valid XML is not a valid RDF XML. So you may have metadata in XML that are, let's say, that are parsable by a XML reader, but before going to the schema validation, you have to ensure that this file is a valid RDF XML file. And here I pasted some of the more common issues. I won't go now into the details because this is really technical. But what I did is that I created a page in our wiki of mobilityDCAT-AP where you will find examples for all these errors and also examples of how you may fix this in your RDF XML file. So now let's proceed with the second part, that is schema validation. So as I said, this is a second step. So once we are sure that our metadata are represented correctly in RDF serialization, we want to ensure that these metadata are also compliant with the mobilityDCAT-AP specification. As Daham was explaining, we may include a different type of constraints in our SHACL shapes that basically reflects what is written in the specification. And to do so, we use SHACL, that is a language to express these constraints. And as part of our mobilityDCAT-AP specification, so on our page, you may find all the artifacts that are associated with the validation, and also all the documentation associated to it. I put it here, the link, and maybe it's easier for you to reach the exact part of our specification that deals with these aspects. And that's the main topic of today's. So this is also what Daham will show you afterwards. And regarding the tooling, also in this case, there are different approaches. First of all, let me cite some libraries that can be used to do this programmatically. Commonly used are PySHACL for Python, or RDF4J SHACL or Gina SHACL for Java. But there are really a lot of libraries also for JavaScript, for example. And you can use the link that I provided in the slide before to find also tools for SHACL validation for every programming language that has a library supporting this. And now, also for schema validation, I will show you also some tools that are available online and that you can use to do checks and experimentations without having to install something on your laptop. So the first one is a tool from the European Commission. Is part of the EU interoperability testbed and is made available both as an online app via API, but also has the possibility of being run as command line tool. And you find here all the link that may be relevant. You see on the right a picture of the interface that can be used for running it online. Then we have the SHACL playground that has different implementations. There is also a newer one from Zazuko, but as Daham will show you, probably is the oldest one, is best because it managed to, let's say, be compliant with the entire specification. And finally, we have also the RDF shape, that is the tool that I showed to you before, that also has the possibility of running SHACL validation as a separate feature. Last but not least, this is something that also Peter already mentioned. As you know, for mobilityDCAT-AP, we have this collaboration process that is based on issues on our GitHub repository. And of course, this applies also to validation problems. So it may happen that we made some errors in our SHACL shapes, that you may have doubts on how to run the validation, or something maybe is not clear in our wiki or in our specification. So feel free to go to our mobilityDCAT-AP repository and open issues related to that. This may also help maybe other users that have the same doubts. And finally, one more thing, there is also another tool that we are providing that we call the mobilityDCAT-AP generator tool. This is a tool available online, so it's like a simple front-end application with no backend, so your data will only stay in your browser. You can test and experiment as you wish without any problems. And basically here the idea is to have a simple form compliant with the minimum profile of mobilityDCAT-AP. And what you can do is you can fill the form, so write some also fake metadata, and you will see how this metadata can be correctly represented in mobilityDCAT-AP. So when clicking on the generate button, the part on the right will populate with the RDF data compliant with our specification. And also here you have a button on the top right that allows you to change the serialization. So you may see how different serializations of RDF can represent the same set of data. And that's all also from my side. If you have any questions, I'm here and happy to answer.
Well, Mario, thank you so much. A lot of tools available. So now you have some knowledge on the tool set that is available for validation, but also for generation of mobilityDCAT-AP. So I don't see any questions in the chat, so we might move on. We have 25 minutes left. Oh, there are questions. Okay. Maybe we pick one here. Okay. Ooh, wow. Edwin is asking, how are the mobilityDCAT-AP connected to transmodel? Can it be used as ontology, although it's not expressed in OWL? So transmodel is a data model coming from the public transport domain, as I can see. So I can tell you, Edwin, that of course we are looking at other ontologies and models in the mobility domain. However, mobilityDCAT-AP is mostly based on DCAT-AP, which is coming from the open data world, while we don't reuse a lot of public transport entities yet, which might change in the future. So we are aware of transmodel, but it's so far there's no big connection. We will probably check the other questions in the meantime, or I will get back to you people at the end of the session, and I will try to elaborate some answers However, I would like to use the next 15 minutes or so again for DARAM, because we have learned something about the concepts, we have learned about the tooling, but now we'd like to deep dive into examples and into specific files that you can use while you're doing your testing and your validation. So DARAM will now come back with some examples and test files which can be applied. DARAM, please.
Yeah. Yes, thank you, Mario, for your presentation. I think also the contents can also be found here. I'm just going to present things as he explained it. For a lot of SHACL playgrounds out there, because we need SHACL engine to enforce these constraints, and a lot of SHACL implemented. We will use this playground. And also this one is, as Mario explained it, it's a very interesting one because you can also visualize not just using SHACL, you can use SHACX and also with different serialization. For example, you can hear all these serializations, and you can also specify which type of SHACL engine you can use for validation, because later we will see some things might be from one engine to others, things or implementation are different. And here also, because for these tools, online tools, maybe for sensitive data is not applicable. Maybe some backends are there, and then people are taking your data. Therefore, the API is also, as Mario explained it, available for Java, for Python, and for every other languages. And here's some notes about these tools. And also some common mistakes. We will see that all common mistakes in our practical exercise. And also that if we want to learn more about RDF validation and about SHACL shape, here's our two resources. One is the W3C SHACL recommendation. Also, this is another nice book. Includes a lot of information about RDF validation. And now if we start with some validation, first of all, for our SHACL shape, we use this playground, which is called SHACL playground. And also you can use Zazuki as well. Here, you can paste all shapes here. The first part called shapes graph, and you can paste your data graph here, the examples we want to validate. And here you can specify which type of serialization you want, because we are using Turtle. As Mario explained it, also this is important to have a correct syntax. For example, if you forget this dot, you will get this error message, and you will see that because here there is no linus, and that's not easy for reading, you can also use this online Turtle validator, which is nicer, and you can see which line you have a problem. And you can see that in this line we have just one dot. And this is important, as Mario explained. First of all, we should have both correct shapes in the syntax and also data graph correctly. And in our shapes, we have, first of all, we can find data graphs in here. For example, we have a lot of examples relate to different shapes we want to validate. All the shapes are here. And for mobilityDCAT shapes, we have here the shape graph, and the shape graphs can find here in the validation. I'm just using this one because there's some this mobilityDCAT shape. Let's go to first for the first example. Here is prefixes and some imports, and then some metadata about shapes. And here's the first shape. We have this address shape. I will explain why we have this shape like this one, but first let's just copy this part to our SHACL playground. Here we update. Now we have this shape, and we want to have this example. We want to validate this example. Yeah, when we paste our data graph here, sorry, we paste our data graph, then we update, we will get the validation message. I will go through this validation message, but before of that, I want to just explain you why we have this shape and where we have implemented this shape, because the SHACL shapes are coming from the specification of our ontology of our data when we data model. For example, here is about, we have this class address. And for this class address, the target class is a location address, which is coming from this ontology. And here we see that the recommended properties are here. For example, administrative area, country, and we have these properties. And if you look at these properties, we are using this location admin unit 2, and the range, the data type of this property is literal. And there's some description about this property. Also, we see that cardinality means this property is optional. At most, we should have one property. If we go to this SHACL implementation here, we see this SHACL. We see that the target class is local address, which is coming from this mobilityDCAT here. And also, if we have checked this property, then we can see that the property, this property should be of type literal, and also this property should have at most 1. And we can also specify here mean count 0 because it's optional 1. And in let's go through the first valid properties. Here in the data property, we have all these shapes has been defined, all these properties, for example, for city, for country, for postcode, and through fair, all of them are optional. At most, we have one cardinality. And here in the SHACL playground, we see, for example, if we create this, let me remove this part as well. For example, if we want to create this, an example of this class, here you see that we have this property with just one data type of literal, and we have post name of locon and so on. For this shape, we see all this criteria is fulfilled, therefore it is passing from our data. But for example, if we come to this locon property, if we, for example, post name, if we write 2 properties for it, like this one, because it's case sensitive, then we will get a violation message. And the violation message is here. The violation means this property should be fixed because it's violate our constraint. And the constraint problem is the max count constraint problem. It says that for this data resource, which is here, has one violation. For the property locon post name, this is property post name, has it has the city must be a literal and can appear at most once. But now we see that it has two properties. It appears twice. Therefore, this is non-valid property, and the constraint is not fulfilled. Then the SHACL returns for us a violation message. If we delete it, now we have no more any other violation properties. If we go to through this example, in the examples I have created two different types of examples, for the valid one and also for non-valid one. Here we have some non-valid examples. Let's go through the non-valid examples here. If we now we have three problems. The problem are, let's remove this valid one. For this first one, we can see messages. The administrative must be literal and can appear at once. And here it says that the max account is 2. you can go here. If you just remove this one, as I explained before, the one error would be gone. Now we have just two other problem. The other problem is here. You see that this is not literal. It's a type of IRI. And because it's type of IRI, and we said that this property admin should be of type literal. Therefore, the SHACL is returning this message error. If we just, for example, change it to string, then this error also gone, because now we have just one error of the last one. And here for this one, we have the blank node IRI. And the blank node is not a type of literal. Therefore, the error is from this one. And what we can see that the node kind constraint is violated. If we delete this one, then this error is gone because that property is optional and the data type was not there. But one thing here in this example, for example, sometimes it's crucial for beginners. For example, if we just copy this example here, now we see that if we copy colon, now we have two properties of this. At most it appears to, but still we see that it's valid one. Because SHACL engine takes these two properties, and because they are same value, then it removes the one property and count as there is just one property. But because data is SHACL engine is case sensitive, if we just change this one, now we got the violation. It means that the data, the SHACL engine is also case sensitive and consider the, if we have same data value for properties, then because it follows the mathematical representation of set, it automatically deletes the other part. And as I said, for example, the HTTP is very important. For example, now we have one violation. If we just change some HTTP or some prefixes of this, now we see that we have not violation, even though there is one constraint violation, because this HTTP, it refers to another namespace. It's not equivalent to this one, which we have in this site, which is that HTTP. Any part of this prefixes are very important. They should be equivalent in order to evaluate the data graph. And for the next example, we can go to, we can copy also another shape, which is agent shape. I think this is the agent shape is long one. Yeah, for agent shape, again, the agent is coming here. We should have one agent, and for other properties, we have one mandatory properties. You see here at least one, and at most n properties. It's no problem. How the occurrence of it's not problem. The data type should be of RDF's literal. And for the rest of recommended properties, we have this scope of scope style. And it's optional. And also for all the other properties, the optional properties here is we have this locon, which is location type, and we have this organization member of, and so on. I have created also some examples for the violation of this property and for the valid examples here. Now, if we just go through just one valid example. Now we have not errors because all these validations are valid with this agent shape. We have one mandatory property, which should be at least once and at most is not problem, which be of data type literal, and the properties is fourth name. And here we have this human readable description of this property. And then the severity level of SHACL is violation. This means if we have violation here, this property should be fixed. And we have this message if the violation is, if the property is not here. You see that for mandatory properties, we have member of property, we have mailbox, and first name is here. This, if you delete this property because it's mandatory, then the violation should come, which is mandatory property. Just a minute. Fourth name. We have this fourth name here. Yeah. Now we will get this one because at least we should have this fourth name, which is a mandatory property. And for other violation problems, I have explained it here inside example. For example, all the other properties are mandatory. And for example, if here we have this, because it's at least should be one, then this is failing. And this is not of type literal, it's of type IRI. Therefore, this property would be failed because in our SHACL shape should be of type IRI. And for this address, because this is the scope concept, and it's a blank node. Therefore, this is also not passing. And here is how we define our shape in this side and how we go to create the corresponding data graph for our shape, and then how we can interpret that validation report. We can see that we can trace back to our data graph where is happening. You see that here in this Dr. Thomas Schmidt, which is this one, say that the mandatory property is missed. Therefore, the SHACL shape is exactly translating this representation into constraints. For example, for assessment shape, again, for this assessment class, we have a shape, which is assessment is defined by mobilityDCAT API. And this assessment has some optional properties like assessment date and assessment result. And the assessment result is of data type. You see in the SHACL shape is here. Yeah, it's interesting because for this property which is issued, we have either data type of date or data type of date time. With this OR class, with this SHACL OR, we can enforce this this constraint. We can enforce this constraint, and you see here, and for the hash body should be of RDF resource. Should be of type RDF resource, and here we have defined that we can use the SHACL class, which is defining the RDF resource and the properties hash body, and here is some message description and violation. So I think we have these examples I have created. You see here that the issue is explicitly mentioned which data type is it, and it's a type of RDF resource. You see this body is referring to this part, and this part is defined as RDF resource. Therefore, this graph is valid. And the same here, we see that the data type, and again, is IRI, which is a type of RDF resource. This is also a valid one. But here, this one is an invalid property because we see that this is string. And our constraint, the data type should be date time. And for this property, we have two date timers. And in our specifications, we set at least one and at most one. If it's more than one, then of course it's not valid property.
I think, looking at the time, The question is, do we need to deep dive more into those examples? I have understood we have a set of files that help people to check positive or negative validation results. And I'm very happy that we put this all on GitHub. So maybe Dan, tell us, we have this entire GitHub repository now with test files which show you positive examples, negative examples, which can be reused by any persons using, for example, the SHACL playground, correct?
Yeah, yes, that's right. Also, I have explained it. What is the reason of non-valid or the reason of the validation of these properties? It's helpful documentation for people which has not a lot of experience with SHACL and SHACL playgrounds. Yes, we can just copy paste things and see on the SHACL playground and a little bit play with changing things. Then we will understand how things are working.
Okay. So really, really nice work, because I know that that kind of guidance helps people like me who are not big experts in validation to understand how it works. And you have positive, negative examples, and you can use the examples here, but you can also use your individual mobilityDCAT-AP outputs that you might have in your own system. So is it okay to make a stop here?
Yes, just one thing, the definition, first of all, we should understand this part, which is the specification of our classes. Then we can check that exact semantics with the SHACL shape, then we can validate our constraints. I think it would be best practice if we start from here. For example, for catalog shape, just have a look of this one, the cardinality, the data type, the property type, and then compare with SHACL shape. We will understand why the SHACL shape is in this way, and then we can validate the examples. Yes.
Okay. Cool. Wow. Okay, so this is like a very, very long story here, but at the end, it's just an offer for deployers to test validations just using those test files. I think it's a very great idea that we are offering. For the rest of this day, I would really like to get back to the audience. We have luckily get some more questions, which I briefly will go through. There are not too many. I have one generic question again from Arthur. Maybe this goes for Mario. SHACL can be used only to validate the schemas used for RDF data exchange, ? I think so. Is it correct?
Yes.
Okay.
Exactly. SHACL is explicitly for validating RDF data exchanges.
This was quick. Maybe, can it also be used to validate the data in an RDF dataset? Arthur's question. I think yes again. Huh?
Yes, exactly. Both a dataset or a data exchange, whatever is in RDF format.
Yes, the dataset in RDF format called data graph. We can say, for the validation of every knowledge graph or data graph, we can use SHACL shape, because knowledge graph is the real instance of an ontology.
Exactly.
Yeah.
And Arthur, you're my friend. You're having great questions. Is it possible to check if a value is between a minimum and a maximum value? I think yes. Again, maybe
yes, it's correct, because in the presentation I present the SHACL range, inclusive in and inclusive. Like SHACL range is also possible.
Okay, and you can also check if a start date is before an end date, correct?
Yes, that's correct.
Thank you.
Okay, so we have a power user I see at NDW. So Arthur will make sure that our SHACL toolset is used intensely. There is some more information on the correlationship between metadata and data, like transmodels. So Mario, thanks for sending this link. I think this is nice to read this on your own. I don't see any more questions. There's one question about using large language models. Oh, yeah, this is something out of my knowledge. Mario, you know a lot about AI. So what is the trend now with LLMs using knowledge graphs?
Yeah, I would say this is a little bit out of scope here, but what I can say is that for sure you need to have great RDF data to use them together with LLMs. So, so the validation is useful to have a good data set that then you can use in combination with LLM. But this is, I would say, not possible to treat this topic, let's say now. Let's say that the two things goes together. So LLM is for the not symbolic word, like neural networks, and RDF is more about the symbolic word, so where we explicitly encode data and the information in a structured way.
Just one comment on this question. Because LLM is just predicting the next token, and knowledge graph is using the exact representation of inferencing. Therefore, due to the hallucination, sometimes if you want to generate an LLM ontology or knowledge graph, of course, you will get a lot of hallucination because it's possible LLM to generate a vocabulary which does not exist at all. That's the hallucination problem. Combining knowledge graph and LLMs make work better because a knowledge graph is based on some exact algorithmic representation and LLMs is a prediction. Therefore, make more reasonable to use LLM with knowledge graph. And the knowledge graph can be an enhancement of reasoning in LLM as well, because OWL is an inferencing language, and then LLM can learn from that.
Wow. This was really interesting to put this in one sentence. Okay, I think we are not at the end of the storyline of RDF, LLM, so there probably will be some things going on and new technologies coming up, which we will follow closely. However, I would like you to recap or to, maybe as a statement that I'm having for you people here in the call. Well, validation is a very important step when you do your implementation. So when you have a national access point, like in an NAP in any country, you will come up with a situation where you have a mobilityDCAT-AP output or export function, and you will go into the testing phase. So the validation technologies and techniques that we have been showing today will help you greatly to go through this process. So it will show you and will make you will enable you to have valid output files in mobilityDCAT-AP. So feel free to use our guideline, our file set, and the references to the tooling that we have been providing. You will find everything on the wiki, but we also do a recap of our webinar today, including our presentations, some links, and of course the recording. For any questions, comments, or support that you have, or support needs that you have, the best way to contact the mobilityDCAT-AP team, including us three, is to go via GitHub. So any issues that are there will be responded by us in a timely manner. So again, we are happy to support anyone deploying mobilityDCAT-AP. So yeah, so there are some more. There's one more note by Emilio using URI instead of blank notes. Okay, so property shapes can be reused or disabled. Yeah, I think this is just a statement. Yeah, thank you for this one, Emilio. Other than that, I would like to close the meeting, and I would like to thank Mario and Darren for providing this very detailed and professional expertise in this webinar. We will let you know about future webinars and updates on validation or on any other topics regarding mobilityDCAT-AP via our website, via our GitHub, and via LinkedIn. So in this sense, I wish you a nice rest of this day, and let's stay in touch. And thank you very much for your audience. Bye-bye.
Thank you, Peter. Bye.